So this is a solution to the second mandatory experiment question in 2014, and it was the one on the refractive index of a substance. If you'd like to skip to any part of this, just click on it. So what's all this refraction stuff about again? It's waves changing direction as they pass into a more or less dense substance, and you can measure the angles I incident and or refracted, and then calculate something called the refractive index, which kind of gives you a clue as to the difference between the two densities. Bigger N, bigger difference between densities. You can figure out if a ring is super expensive and worth so many thousands and thousands of euro, or if it's worth less than €1 and it's made of plastic and you got it from Claire's Accessories. So the first part of this question, you've got to say which of these angles is the odd one out. You've got to have a look at it. It's not hard. Look, they're all going up in a perfect staircase, except for one of them. It's 23. What is it doing? It's gone 27, then back down to 23, then up to 36. It's completely the other one out. It's 4 marks, easy peasy. Then for the next bit, you just do a label diagram with how the student found out that angle of refraction. There it is in front of you. You've got to put down a protractor, a glass block, a laser, angle of refraction. You just got to make sure you put the labels down. Don't just draw a picture and go on to the next page. So you get a total of 3 marks for 4 of those labels. So in the second part, you've got a label diagram of the experiment. Here it is. You've got your protractor, glass block, laser. You've got to mention the angle of refraction there. Careful, that's the one between the normal and the ray. Classic mistake. People put it between the block and the ray. No, it's the normal. Always draw your angle between the normal. And that's pretty much it. You just need 4 of those, 3 marks each. Not so bad. For the next part here, you need to do a graph. Before you do that, you've got to redraw that table, taking the sign of each I and or. So for example, you take 20, you get the sine of that incident angle, and that'll be 0.34 in this case. So you type in your calculator, sine 20 equals, watch out, calculator should be in degrees, not radians, classic mistake, and that'll give you a new point. So just write out your table again, and we can use that to graph the next bit. When you're getting the slope of your graph, you can use the kind of algebra method here, the y2 minus y1. You can use the kind of visual method, how high the triangle is divided by the base of the triangle. You can use that for the slope. And you can also, well, the average one is, we'll give you a rough answer, but it's not great. And in fact, they even ask you a question about why that's not as good a method later on. And here's another thing to watch out for. That 23 degrees you found was the odd number at the start. You should be leaving that out of your graph. If you put that back in, it's going to drag your trend line up, and it's going to give you a slope of about 1.35 as opposed to the correct one, which is the 1.44. So you just could get rid of that completely, and that's a much nicer trend line. Look at that lad there. Okay, and 1.44 is about right for the substance we're looking at. Because it's a property of the actual material. You know, every year in the Leaving Cert, glass has the same refractive index every time, unless they use a very different kind of glass, but it'll always have about that value. So in this bit, they ask you about that average method. It says, using a graph to calculate the refractive index is better and more accurate than calculating it with a pair of each angles and getting the mean, the average. Why is this? It says 2 reasons actually. It's probably easier to give one, but you might have to think about 2 separate ones. Well, here's one. The outliers are really easy to see. So look at that guy sticking out like a sore thumb. When you put it on a graph, it's clear as day. Whereas if you have a table of data, our table was small, but imagine a table had 1,000 numbers in it. You would not see what number in the table was the odd one out. Put it on a graph and it's clear as daylight. And the second one is that a slope gives you not just a simple mean, it gives you a weighted mean, which is much more accurate.